Good afternoon, dear student. I am Arnab Das. Today I discuss about the Huffman Code. Huffman Code achieves the minimum code word length amongst all other coding algorithms, and for this reason, this is also suggested as name of compact code. By using few steps, you can got the code word, and for this reason, you have to identify initially the number of stage, how many you have to record, that is small n is equal to a capital N minus of r by of r minus of 1, where capital N is defined how many number of symbol is used on there, and small r is defined what is the r array on there. If it is a binary form, that time the r will be 2. If it is a ternary, it will be 3, in such a way. Step number 2, you have to check that is the small n is coming as an integer one or not. If it is a integer one, that time it's okay. Otherwise, if it is a fractional one, then obviously you have to increase the symbol value, and the symbol will be as a 0 probability. Okay. For the step number 3, you have to arrange the probability as a descending order. That means the probability column should be the highest value will be the uppermost, and the least one value will become as the last one for that particular column. Step number 4 will be you have to add the last r probabilities, and then you have to put the added data at the next stage with the following the same condition, that is the decreasing, or this is descending order form. So for the next stage their number of element will be r minus of 1. For the step number 5, you have to follow the number 4 step one after one. Ultimately there are element will be present for the last stage. Okay. Now for the step number 6, you have to put the value for the last stage as a 0 1 up to r minus 1. If it is a binary one, that time the value will be only 0 and 1. If it is a ternary, it will be 0 1 and 2, and this process will be repeat towards the left direction for the step number 7. By using an example, I think it will be better for understanding. Let an example where a b c d e f g total 7 number of symbol is used on there with their individual probability. As you say, for the a it is 1 by 3, for the b it is 1 by 27, for the c it is 1 by 3, in such way. The question is that you have to design a Huffman code for the binary and also the ternary coding. So first step is you have to identify how many number of small n is there. That is the how many number of stages you have to record to get the ultimate coding data. To get this one, you just put the value for the appropriate position for the equation one. Just say for the n, you already know that from a to g this number will be 7, so you put the value n equal to 7, and for the binary one there r is equal to 2, so this value position you put as a 2. So the ultimate value for the n will become as a 5, and that one is a integer one value. For the next step, that is the step number 2, it is told that you have to identify if the n is not an integer number, that time extra symbol you have to add with the 0 probability. So step number 2, it is not required to add a extra symbol on there because small n or stage number is here integer, and that is the 5. Look that for this reason we just write down as a stage 5 on there. Stage number 5 is on there. Okay, this is stage number 5 is the last one. So now for the step number 3 is that you have to arrange the probability into descending order. We just use this as in descending order, that is the 1 by 3 is the highest probability on there, so a is the first one, for the c also the 1 by 3, so you can alter the position also, that is c is the first one, a is the second one, but I just write down as a symbolic name on there. This is a is the first as a 1 by 3, c is in 1 by 3 also, d as a 1 by 9, and ultimately for the g also 1 by 27. And step number 4 is that you have to add the last two probabilities. In this case, F and G is the last one, and you added this by using this circle one on that. If you add this 1 by 27 and 1 by 27, that time the result will be 2 by of 27. So this is the higher value rather than the 1 by 27. For this reason, the 1 by 27 is the least one for the stage number 1, and added result is 2 by 27 is put at the upper of that particular one. So for the next is, that is the stage number 1, the resultant data is coming in this position, and the 1 by 27 is applied for the F is applied as such, that is the 1 by 27 on there. Okay, now same process you have to apply on there for the step number 1. Their stages 2 last data is added on there. Now if you add the 2 by 27 and 1 by 27, 1 by 27, and that time the value will become as a 3 by 27, and this is 1 by 9. So this is the same one on there, so not required to alter the position on there. So added data is put it and the last position on there looked at, and the E probability is put it as such position for the previous one case. Now again you add it for the stage number 2, the last two probabilities. If you added these last two probabilities, that time the result will be 1 by 9 plus of 1 by 9, it will be 2 by 9. So 2 by 9 is higher than the value of 1 by 9, and for this reason 1 by 9 for the E will be as a lower one position, and the added result, that is the 2 by 9, is put at the upper of this 1 by 9. Look that this is put it in here, and this is 1 by 9 is this position. Same process is applied for the step number 3. Here also last two probabilities are added, that is the 2 by 9 and 1 by 9. If you add these two, that time the result will become as a 1 by 3. So this is not required to alter the position for the C also. So the same process is going on there up to the step number or stage number 5. So now we ultimately got a 2 by 3 for the A, and for the C position their stage number 5 is coming as a value of 1 by the value is 1 by 3. Now we ultimately reach the position where the R is equal to 2 is coming. That is the only step number 5, the two data is present. This is 0 and 1. You are applying for the starting for the 0 for the 2 by 3 and 1 by 3 is 1, and you have to go to the left hand side by using the as a prefix. Look that for the 2 by 3, for the 2 by 3 is the result of the 1 by 3 and also 1 by 3. So for these two position the prefix will be 0 0. Look that, because here for the 2 by 3 for the stage number 5, for the stage number 5 the prefix is 0. So this 0 is used as a prefix for the 1 by 3 for the stage number 4, and also 1 by 3 will be used as a 0, and then this one will become for the 0 0 and 0 1. Now you have to check for the below 1 1 by 3, this is coming below 1 by 23 is coming by using adding of these two ones. So 0 1 will be now as a prefix for the stage number 3 2 data, that is looked at in this position 0 1 is used as a prefix for these two. Now again 2 by 9 is coming by adding of these two. So for this position the prefix will be 0 1 0. Look that this is 0 1 0 will be used as a prefix on there, 0 1 0. The same way you ultimately reach the last one position, that is stage number 1 also. So you can got the individual symbol, the probability on there. As is, we see that for the A it is coming as 1, for the C the code word is 0 0, for the D is 0 1 1, and E is the 0 1 0 0, and lastly for the G is 0 1 0 1 0 1. So this is for the Huffman coding technique by which you can generate the code word. And thank you for listening this lecture.